Hey, Pat and Chris back for another episode of Shop Talk. Chris, what are we going to be covering today?
Today we're going to be talking about all things Ranger clutches, some of the technology, how it works. We're going to answer some questions that we hear all the time. We're also going to talk about some of the improvements that we've made to our clutches over the years. So we're going to start with some of the basics of a CVT. The first thing is like, what is a CVT? Are there one clutch? Is there one clutch in a Ranger? Are there two clutches? Pat, why don't you show us some of these basic parts and kind of talk through what they do?
Absolutely. So the first thing we got sitting on the side of the table is the outer clutch cover here. So big piece of plastic, basically sits on your Ranger, kind of right behind the driver's seat or behind the back on a crew. Once you pull that off, you're left with something that looks basically like what we have on the table here. So you've got your belt, your primary clutch, as well as your secondary clutch. You might also hear these called the drive clutch and the driven clutch. They mean the same thing. So primary, secondary, either way, whichever way you want to call them. So as you look at these, the first one here is what bolts to the crankshaft on the engine. So this thing is going to sit there, and spin anytime the motor's running. The secondary is bolted to the input shaft of the transmission. So this one is only going to spin basically when your wheels are moving on the vehicle.
Can we show them where this actually is on the vehicle?
Yeah, absolutely. Let's come over. Yeah, so we ripped the rear tire off. And if you look, we've got the clutch cover off this Ranger right here. So you can see the primary is here, bolted to the crankshaft, your belt is here, and the secondary is here, connected to the transmission.
So when you start your vehicle up, it starts idling. Like what's happening with these clutches?
Yeah, so what you'll see if we were to start this up, and obviously don't have this open and do that if you're when your hands are near here, but this primary clutch will start spinning with the crankshaft. So when the engine's running, you'll see this clutch spinning. The belt and the secondary won't be doing anything at all. As you get into the throttle and start revving up the motor, what you'll see is that this clutch will actually start to pinch and grab that belt, cause the belt to spin, and then it'll actually get this secondary to start spinning as well. The reason that this can spin is that this machine's in park since we got it up on a stand.
Yep.
If it were in a gear like high, low, or reverse, if we spun this, then you'd start to see the shafts and wheels spinning as well.
So Pat just showed us where these parts are on the engine. So you've got your primary clutch, also called the drive clutch,
You got
right?
it, yep.
You've also got your secondary clutch or the driven clutch. Now I want you to kind of explain to us how these things work and what they are. Let's maybe start with this primary clutch. And Pat, can you show the viewers here how this actually works? What's happening in there?
Yeah, absolutely. So if you look on the inside, you've got two different sheaves. So these angled parts of the clutch, the one that goes to the side where the engine is called the stationary because it doesn't really move. The other side is the movable because it actually slides back and forth as the engine revs up and down. And if I set it on the bench and kind of press my weight down, you'll actually be able to see how that goes in and out. So the way this works really is that there's a spring holding it open right here, and there's some shift weights that are underneath this triangular part that's called a spider. And as the engine revs up, these shift weights are actually going to bend out. So they're going to push against that spider to overcome the spring force, which is going to cause this movable side to go in, pinch the belt, and then get it spinning as the clutch and engine revs up.
And how does that work? How do those weights actually push on that sheave to make them squeeze together and pinch the belt?
Centrifugal force, man. So think about somebody like rocking a hula hoop, getting the hips going and it keeps it out there. It's kind of the same idea. A spinning bicycle wheel, anything like that. Once you get the primary to engage the belt starts to spin. That starts the motion of the secondary here, which the difference here is this one actually starts in kind of that closed position.
Yep.
And then as the engine revs up, it's actually going to open up and let that belt go down into the clutch. So when you think about this, like an easy analogy you can think of is like, most people have ridden a pedal bike, right? That's got some gears.
Yep.
So think of your mountain bike. When you start out, what do? You shift down the front sprocket to the lowest gear.
Yep. Pedaling really fast.
So you got the small gear in the front, you got the big one in the back.
Yep.
When this starts out, this is like the small gear in the front where the belt's way down on the inside. And this one's like the big gear in the back where the belt's way on the outside.
So that's when the engine's spinning a little bit slower when it's
Correct.
first starting, like at idle.
Yeah, you got it. So as you rev that motor up, that's like you pedaling faster, and you realize, hey, I need to start upshifting. So what do? You start going to the bigger gear on the front, where down by your pedals, and you start going to the smaller gear in the back. And then, as you're going around and you hit a hill, what do? It gets harder to pedal, right? So you got to shift down again. And this is going to do that automatically for you. So this secondary is going to start to close and drive that belt back out to the bigger diameter. And the primary, as the engine kind of bogs down, is going to start to open back up. So automatically, this thing is going to be going in and out on both of these based on what the conditions are you're driving in. So it makes it super simple for you to operate because you don't have to think about it as a driver.
Awesome. And that's why you call it a CVT, or a
continuously variable transmission. You got it.
Because it's varying all the time.
All the time. Yep.
So why would you want to have something like that that's continuously variable in a machine like this that's doing utility work? Why is that better than like a direct transmission like I've got in my truck?
Yeah, so when you think about when you're going in off-road terrain, what do you encounter, right? It's not all just like smooth gravel paths, right? You're gonna get out in the woods maybe when you're, felling trees and hauling firewood, and you're gonna be going up and down hills over, fallen timber, and you need something that can adjust to that varying condition automatically so you don't have to think about it, right? So like when you're doing like work like that, what do? Lock the transmission in low because you're not going fast,
sure,
right? Let these clutches run in and out and just cruise around where you need to go.
So let's try that like in a scenario. So let's say I'm just cruising down the trail, I'm in low gear, I'm going 10 miles an hour, and I'm starting to come up to a hill.
Yep.
Can you show us on these clutches, like what is actually happening once I get to that hill and I start to go up it?
Yeah, so if you were going 10 miles an hour, this thing would be in. That's going to be a little hard for me to do, but the shift weight would be
get in the gym pad.
Pushing up, yeah. And it would actually start to go back out. Now, it wouldn't go all the way to this idle position, but it would start to come up.
And that's like you said, gearing down on your mountain bike, right?
That's like, yeah, so that's like as the engine speed starts coming down,
yep,
it'll automatically release to allow the engine speed to come back into that sweet spot where it's really building torque. On the secondary that's connected to the transmission, it's going to be, kind of wound out. It's going to start to backshift and actually go closer to that, fully closed position to get you down to that basically lower gear setting. So when you hit that hill, you've got the power to climb it.
And you don't have to shift down into a lower gear, you're just already there.
Correct. Yeah, and again, I think when you think about gear choice, like that's a big deal on a Ranger, right? If you're just cruising trails, like high gear is just fine. But if you're really doing work, I think about what I use a Ranger for a lot is like doing wood hauling. I'm going out, cutting trees down, sectioning, sure, right, hauling them back. Low, like I don't even shift out of low ever because I know that I want this clutch to engage that belt and not slip. And if I was hauling a lot of weight and doing that in high, then I would risk ruining the belt and potentially wearing out the sheaves of the clutch.
And that's kind of a little bit different than like a pickup truck, right? In a pickup, you're typically driving in high gear most of the time, and if you need to haul a trailer or something super heavy, you shift into low. But why would people want to be in low gear most of the time on a Ranger? Or why is that important?
Yeah, so when you think about it, and we have these clutches kind of sitting in the belt, right, to begin with, but as your engine starts to rev up, you're really relying on actually pinching that belt to get the wheels and the vehicle moving. So kind of the weight of the machine, is all going through this belt. And if you're in high gear in the gear selector, what's going to happen is if the weight of the vehicle is really high or you're in like a really stuck condition where it's hard to get those tires moving,
yeah,
you're basically going to start spinning this clutch without the belt matching its speed. So it's going to actually be spinning the clutch faster than what the belt can basically handle, and you're going to start wearing the belt down. It's a condition we call spin burn, where you'll actually basically engage kind of where it wraps around the primary here, and it'll actually basically wear down the belt in that area.
Sure.
So a lot of times when people do that, what they'll complain about is, afterward, they'll maybe smell some burning belt, or they'll smell some, something coming off. The other thing that they'll typically pick up on is as they accelerate their vehicle, it'll feel a little, not smooth. It'll kind of go goo.
And that's because this belt is actually slipping on the sheaves inside of the clutch.
Well, what's happening there is actually because you end up then with a small spot in the belt. So if you look at the width of this, right, it's kind of a uniform thickness all the way around.
Yep.
When you spin burn, what you'll have is a short section, because if you think this kind of is this shape, basically the area that wraps around that primary clutch will get worn down. So as this rolls around and the clutches have to adjust into that thin spot, they'll basically be going like this every time it goes by. And that'll cause it to shudder a little for the feeling of the vehicle for you as a driver.
All right, Pat, so you talked about how the Ranger clutch design is pretty tried and true. We've been using a similar design with CVTs for a long time. But we have made some improvements on these clutches in the last couple of years. I want to go through some of those improvements for the viewers here and have you explain some of, why does that matter, what's important, and what's the benefit of it.
Sure.
So the first thing that we've done in our facilities in manufacturing is improve the balancing process. Pat, can you kind of explain what is balancing? Why do you need to do that? And what's the benefit of improved balancing?
What is it and why do we care? So I think the easy analogy is think about like the tires on your car or truck, right?
Sure.
When you go into the wheel shop, what do? They put it on a machine, spins up, and they add weights where they need to so that it's smooth and you don't get a bunch of shake in your steering wheel. Well, it's a similar idea here. We put each of these clutches on a stand with all the parts together, and then instead of adding weights, you can see there's spots that we drill out on the edge of the primary, and on the secondary, it's kind of on the side of the sheave here. And what that does is it really makes a smoother operating driveline, so you don't feel it, getting out of balance or wearing parts out prematurely. Yep.
Awesome. How about laser alignment? So we've added some pretty fancy tools in our production facility in Huntsville, Alabama. We're actually using lasers to line these clutches up.
Yeah.
Why is that important? Why do they need to be aligned so perfectly, and why do we need a laser to do it?
Yeah, so the whole key and the reason that we want to make sure that the belt is properly aligned in these clutches is so that when the engine's running, that the belt isn't getting drug and trying to spin this secondary clutch. Because when that happens, it makes it really hard to shift gears as an operator, right? And it's really a pain in the butt when you go jump in your vehicle, start it up and go to shift and it's hard to pull that lever. So when these are properly aligned, this one can spin, this one can stay still, and you get that smooth, easy, like butter shifting.
Sure, awesome.
Yep.
Now, how about some of the improved wear parts? Like, explain in layman's terms, what is a wear part?
Yeah.
And what are some of the things that we've done on these clutches to make them last longer, make them more durable?
Yeah, sure. So if we start out on the primary side, typically the things that you'll see wear are going to be these shift weights that are in here. If you get somebody that runs at the exact same speed all the time, this clutch will shift down and it'll kind of sit in one spot and it'll actually notch where that rides against the roller. The buttons are these thin little parts that go between this spider and these towers, so those are a wear item because they slide up and down throughout the life of the vehicle.
You gotta slow that one down for me. So what is a button and what's the purpose of that?
What is a button? So let me grab something that's small here. So if you look where I'm pointing with this little end of the pliers, it's this little guy right here. And what that's doing is allowing this piece of aluminum to slide against this piece of aluminum without touching each other. Because if they did, they'd gall and stick. So
and that's when these sheaves are opening and closing. You get this surface that's rubbing on this surface.
You
so
got
the buttons are meant to prevent that from wearing out.
Yeah, correct. The other thing that we've done is inside of this weight here where it goes through this pin, there's actually a bushing, so that allows it to move more freely.
Sure.
So you get smoother operation of the clutch. And then when we shift over to the secondary here, I'm actually going to pull this one apart so you guys can kind of see what's inside. But there's rollers right in here. So there's 3 rollers that ride down in this thing that's called a helix. And these are actually made out of an improved material so they don't wear out as fast. So you get better longevity out of those. But those will, kind of wear over time and you can swap a set out. And if you look at the back of this guy, there's also been some big improvements on this bushing that's on the shaft. So this slides onto the transmission, and on this version you can see that it's encapsulated. It can't shoot out the backside, so that helps protect your transmission input shaft seal. And there's another hog ring down on the bottom to keep that locked in place for better wear.
And this whole sheave, I think, is redesigned, right? Can you explain some of what's different on that, or how it's different to the old ones?
So when you go back a few years, this has actually grown. So the size of both of these got bigger. We've also added this baffle plate, so we get much better airflow on the back side of this clutch. So when you think about how you strip heat out of this belt to keep it cool, you got to pull it out of both sides, kind of into both sides of the clutches.
Sure.
And this really helps with kind of the back side of the secondary here.
So you mean these ribs on the back of these clutches actually have some real purpose, right?
Yeah.
So can you explain what these grooves are, what they're doing? We'll show you guys on a vehicle later, but can you talk through what is the benefit of having these things on here?
Yeah, absolutely. So if you look at the back of that clutch, the back of this one, the front side, they're basically big fans. Is exactly what they are. So as these things are spinning, they're pulling air in, shoving it around here, and then pushing it out to be able to pull the heat out of this aluminum and pull the heat out of the rubber. Of the belt. So yeah, it makes it, that's really what keeps the belt lasting in a Ranger so long is the amount of airflow and the fact that we're pulling it out of both sides of the belt into both sides of the clutches into the air and exhausting it out. So I've got 4 tools sitting on the bench here. These all come with your toolkit in the glove box of your vehicle typically. The first one I want to show you is actually kind of a two-piece tool. So it's got an 8mm hex on one side and a square drive on the other. So when you pair it up with this tool, you can either go this way for kind of fast turning, or this way if you need a little bit more torque for breaking loose. But what this guy is for are really these bolts that hold this clutch cover on. So if you look, this fits on here perfectly to allow you to unspin these screws that hold this plastic outer clutch cover on. So that's what these two guys are all about. Next one here is this handy pair of pliers that's got a couple screwdriver tips on the backside. This thing's for a multitude, but this red plug in the bottom of your clutch, this is really handy where you can either grab it with the pliers to loosen it up or use the screwdriver end. And this is actually a water drain. So if you ever suspect you've got water in your clutches and the belt's slipping a little bit, you can put it in neutral or park, pull this plug out, any water will come out because this sits on your Ranger like this. It's kind of the low spot. And then you can use that fan action from the clutches to actually rev the motor up a little bit in park or neutral and blow the rest of the moisture out to get it all dried out in there. Then put your plug in and get back to working.
So this is just like putting a fan on some wet clothes to just dry everything out and get it running again.
Yeah, you got it.
So you talked about if you suspect that your belt might be slipping, what are some things that you might notice as a driver that would tell you that your belt's slipping and you should take that cover off and check it out?
Yeah, I mean, the biggest thing you'll notice is that when you put it into gear and you start revving up the engine, that the motor revs up faster than you're used to hearing it rev up, and that the vehicle doesn't start moving, right? Or it moves slower than you're used to it accelerating from a standstill. So that's going to indicate that the clutch is trying to grab the belt, but it's not actually doing a very good job and it's slipping. So the wheels aren't moving as fast as they should, and it's allowing the motor to rev up too much. Okay,
so if you've just gone through some water that was deeper than you thought it would be, or you start to notice some stuff like that on the trails, first step is you take that red plug out, put your vehicle in a neutral or park and rev it up a little bit so those fans can dry everything out.
Yeah.
Then it sounds like the second step is, if you're still noticing anything, either take that clutch cover off yourself and inspect it, or else get it to a dealer and let them do that work for you.
You got it.
Okay.
Yeah, so there's one more tool too that we have here, and this is kind of a cool one that a lot of people don't realize what it is. But if you see the threaded hole on your secondary, this is actually meant to thread in there so it makes it easy to get your belt on and off. So as I start threading this in, what you'll see is these sheaves start spreading apart. And it's really easy to do this on a bench, but we could even do it on a vehicle. It's the same idea. But basically what you're doing is opening this all the way up so that that belt can ride down in so that you get more clearance to be able to pull it off between the two clutches. And then when you're done, obviously, screw it back out, spin that clutch a couple times to get it to seat back in and put your cover on and away you go.
And so the purpose of that tool is when the belt is really riding towards the outside of this clutch, there's so much tension on the belt you can't pull it out of the vehicle. But when you're spreading those two things apart, it allows you to sort of build some slack, and then you can slide your belt off. And
maybe let's just walk down and we can show you real time on the vehicle here. And what you'll see for the guys on the screen here is right now the belt's all the way on the outside. Yep, keep going. Bury that thing all the way down. And as you spread those clutches out, you can see the belt.
You can see it starting to get loose down here.
The belt's starting to drop into that secondary, and it's starting to get some slack.
All right, we're just about there.
Just about there, yeah. So then the easy way to pull a belt, pretty simple, and I think you're probably where you need to be there, is if you start at the bottom and kind of work your way around. If I did this with two hands, it'd be way, way easier. But you slide it off the secondary, and then you slide it off the primary. And the one other thing that you want to realize is you see how it's got Polaris and then the part number across the belt here?
Yeah.
You always want to be able to read that from the top down when you take a belt on or off. Because that way, if you've broken a belt in properly and you want to keep it as a backup or a spare, that the angle of the side of the belt is going to match the angle of the clutch sheaves.
Okay.
Yep, so you don't want to take one off this way, spin it around and put it back on. You always want to keep them so you can read Polaris and the part number from the top down.
Okay, that's a good tip.
Yep.
So you just talked about how this belt actually mates up to those clutch sheaves and actually matches that profile really well. So I know that's the important reason why you need to break in your belt when you get a new Ranger. Can you walk us through some of that?
Yeah, absolutely. So if you look at the side of this belt, right, it's basically at an angle. You can see it's kind of tapered here and tapered here.
Yeah.
And when you look at those clutch sheaves on the bench, same way, right? You've got a taper on either side of them. Well, as you get a brand new belt, it's never like perfectly flat against each side of the sheave. It's always off just a skosh. And during the first, few miles of driving, what's happening is you're actually wearing the belt down to be able to perfectly match the angle of those clutches. So when a belt is brand new on a brand new vehicle with brand new clutches, you don't actually have the full power transfer capability of that belt until it's fully broken in. So once that belt is perfectly mated to those clutch sheaves, then you're at the point where you can get the maximum power transfer and do the most amount of work. So it's really important, like when you get a new Ranger at a dealership, when you're going to load it on the trailer the first time, like put it in all-wheel drive, shift it to low gear, and get into the throttle enough to get the wheels moving. You know, you don't have a torque converter like you do on your truck, so you actually need to get into the throttle enough to get everything rolling versus just easing into the throttle and letting that belt slip on that primary.
Make sure you guys like, subscribe, and comment. If you've got questions about clutches, you've got future topics that you want us to talk through, let us know in the comments. You might see a future video coming up.